Another requisite of this workshop is to have Notepad++ and Python installed. So I've sent both those links in the chat already. If you haven't installed it, do it now. And yeah, let's go into the next slide here. So this workshop is part of a three-part workshop series where I'll start with teaching a little bit about Python programming, variables, loops, and functions. That's generally what we're going to be talking about today. Then we're going to talk about in the next one, intermediate Python programming. We'll get into what classes are, package managers, anaconda, environments, and that sort of thing. And then the last one in this series is a lot for the graduate students who are planning to do any sort of like machine learning or AI in the future with TensorFlow, or if in the applications of wireless communications you want to do it, if you want to do it in the aspect of finite element, something FEM stuff as well. You can do it there. If you're doing electromagnetics, you can do it with image reconstruction. There's a lot of aspects of machine learning that are being introduced in our graduate curriculums and research, so I wanted to have that as an option at the end. I've also added a complementary workshop to this. It's turbocharging your coding with VS Code. Now I have put in the link in the chat already for VS Code. VS Code is a text editor that is really customizable, and it's great for coding. Today we're just going to be using Notepad++, but if you want to go to that VS Code one, I think it's a great option. You'll learn a lot in that, and it'll really make you that next level of programmer that you want to be. One thing to note though, this is the Introduction Python Programming, the one that you're at right now, is the only free one, like available to anybody who wants to attend. The rest of them, you have to be UMIEEE members, but I'll talk a little bit more about how you can become a UMIEEE member at the end of this presentation. We don't have to worry about that too much right now. So, but yeah, if you want to take a screenshot of this, I already shared the slides with you, so you can have this, and we'll be in touch about when these dates of these programming workshops will be. Okay. A little bit of agenda and a timeline of what's going to be happening today. We're going to start with talking about the types of variables in Python. So Python is a little bit different from programming languages like C or Java, where you have a lot of control over the types of memory that you have. And Python variables are very simplified, almost like JavaScript-esque. We'll talk about the mathematical operations, just like how to do basic math in Python. We'll talk about how to do formatting strings, so F strings, and how to do print statements, which is really good for debugging. Don't tell anybody I said that. You'll talk about direct for loops, indirect for loops, and while loops. So we'll talk about the different types of accessing iterables in this, and then we'll have some fun with functions. And then at the end, we'll talk about how to import packages and functions from other libraries, so that if we're doing stuff that's using open source libraries, we can take advantage of other people's work. Yeah, so that's kind of like a general idea of what's going to be going on here. Does anybody have any questions about the timeline, the agenda? Does anybody have any issues also with the IDE? Seeing none, I do recommend, if you have two monitors, put my screen that I'm sharing on one monitor and keep your own monitor on one side. If not, you might want to do some window rearranging so that you can see what I'm doing at the same time of what you're doing, or you can just simply look at what I'm doing, and there will be a recording of this at the end, and you can review it at your own leisure. Okay? All right, so let's get started here. I have Notepad++ open right here. I put it into dark mode. If you're wondering how I did that, you go to Settings, Preferences, Dark Mode, and Enable Dark Mode. And that's it. A little bit easier on the eyes. Yeah, dry eyes is a real thing, so just be careful of that. Okay, so let's say I want to do something in Python here. Very simply, let's create a variable. So I'm going to create a variable called x equals 3. Now you're going to see, and I'll make this a little bit bigger so it's viewable. Zoom in. There we go. Just a little bit more zoom in. Just control mouse. There we go. Yeah, darkness. Okay. And then we have x equals 3 here. So I want to save this file, and we're going to get some little bit of formatting going on here. So I'm going to go into downloads, tutorials, and I'm going to name this main.py. Now it's important when you make files in Notepad++, you specify the file ending. You can see all the different possible file endings here. I'm going to click Python just to make sure that it says it's a .py. So all your Python files will always end in a .py. Like C ends in a .c and R ends in a .r. Python is .py. Okay, cool. So we saved it, and we can see we get a little bit of syntax highlighting going on here. So it says x is equal to 3, and 3 is going to be blue because it's a number. Okay, so 3 is an integer in Python. An integer in Python, unlike other programming languages, can actually be any length, and you won't have any loss of precision. So if you've ever used C programming before, you know that there's 8-bit integers, and if you go above 255, it will loop back to 0 if you're using unsigned ints. And if you're using signed ints, it'll go to -128. So in Python, it's really nice. You don't have any of the problems, but you do have the associated overhead. So in Python, I can actually have a crazy large number like this, and I don't have to worry about stuff like in C where you would have to do something like long int, unsigned int like that. You'd never have to do something like that in Python, which is nice. So I can have an absurdly large number like that. And let's say I wanted to double it. So in Python, if you want to double something, we're going to say x is equal to x times 2. Very straightforward. Okay. What's something some of you who have done programming in C, Java, or other programming languages notice about something missing at the end of my lines here? At the end of each of these lines, what did I miss? A semicolon. That's right. Fortunately, in Python, you'll never have to worry about a semicolon ever again. Semicolons don't actually do anything in Python. People say, oh, they do, does bad stuff in Python. It doesn't actually do anything. You can have it, you can not have it. The only reason that you would ever want to have it is if you wanted to do two statements on the same line. That's the only reason you would ever have a semicolon. Only really use case. Otherwise, you keep it on the other line, and you can end it, and the Python interpreter will see that end of line. All right, that's the end of the line. Okay, very, very handy. Okay. Let's talk about other mathematical operators here, or actually types of variables. So I want to do something else in Python. Let's say I want to make this a string. So if I want to make a string in Python, let's say I have some string equals to this is a string. So the cool thing about Python is you can have your strings just like in JavaScript with single quotes, double quotes, and you can even have it with triple quotes. What does triple quotes do? So if you are of C descent, if that's okay to say, you will know that if you wanted to print something and have a new line in it, you would have to do something like this is a string with a new line. And you have to put that \n to tell whatever you're printing out to that there needs to be a new line there. Python, a little bit simpler. Some people use this, I don't. You can have triple quotes, and you can say this is a string with a new line. And that new line character actually gets embedded into this triple quoted string. Kind of useful if you wanted to have, let's say, something like, let's say you wanted to have something like menu for program. And you want to say something like, all right, 1 moves character up, 2 moves the character down, 3 moves, and you get the idea. So you can actually have it like this, and you can just print it out, and it'll look very nice, and you can read it and edit it very nicely in your text editor, and you don't have to worry about oh, where's the new line character, having lines that stretch on literally for 80, 90 characters. Okay, so three different types of ways that you can make strings in Python. Another thing to know in Python, there is no such thing as a character. So in C, you could have something like this, and it'll say string is a character, and that's the character. It's literally a byte. There is no such thing as characters in Python, at least not technically. Everything is a string. All characters are strings, and is new creating new lines only possible with triple semicolon. So the triple quotes, yeah, you can only really do that with the triple quotes. So you can't, for example, I can't have it like this. This doesn't make any sense. You can have a single quote, double quote like that, and you can't have it a single quote either. One thing you can have though is you can have triple single quotes, and that will still work. Okay? It has to be triple the quotes, whether it's double or single quotes, doesn't matter. Okay? They also have to be the same, so I can't have it such as, I can't have it something like that. Doesn't make sense to it. Okay? Alright, what's another type of variable that we have? We have floats in Python. So you can have 0.2. Now, one thing to know in Python, you might think, oh, well, if integers have infinite precision, so will floats. No, that's not the case. For some weird reason, they don't. So all floats are, I think, by nature, float 64. So you have 64 bits in there for the float. IEEE 754 standard. If you want to research that on Google, you can take a look at that. IEEE 754 64-bit tells you a little bit about how they're going to be storing the floats and how many digits of precision you can have with that. Okay, what other type of variable do we have? We have other types of variables such as objects that we won't really talk into yet. There's also bytes in Python, so you can have stuff as bytes. So you can have I forget, I think it's 0b01, something like that, and that'll actually create it as a byte rather than as a binary integer. I could be wrong about that. Usually don't use bytes. So mostly you'll use integers, floats, or strings. Okay. Any questions? Does anybody have any questions on types of variables I may have missed? Okay, seeing none, let's talk about the mathematical operations. Okay, so let's say I have a variable called x, and we're going to say x is equal to 64. Okay, if I wanted to double x, in Python, there's a way of doing this. It's x equals x times 2. So that's the multiply operator. Okay, let's say I wanted to divide by 2. Okay, so you might think that this is divide, and you'd be semi-right. So a problem with division in Python is that dividing like this actually converts x into a float. So after this, x is a float afterwards. Okay, so there's two types of division in Python. One is just normal float division. The other one is integer division. So to do integer division, you use 2 backslashes when you do it. And that will make sure that x is exactly 32. Okay? Otherwise, it could be 32.0, and I'll go into the problems of floats not having infinite precision, and that might screw up whatever you're doing. Okay. Adding and subtracting is pretty straightforward. Plus 3, x is minus 3. What if I wanted to do modulus operator? Well, that's the same thing. So I can do x modulo 3. That also works. What else? Exponentiation. So how would you do exponentiation in Python? Well, It's a little bit interesting. You think it was something like this. This is not the case. In Python, the caret operator is actually an exclusive OR operator. So if you wanted to do exponentiation instead, you do a double star. So this is exponentiation. I'll put modulo operator, subtraction, and addition. Okay. Would anybody benefit if I went through the binary operations in Python, or is that not needed? If you would like to see the binary operations, I can do that. I'll give you just a 20 seconds here to put something in the chat if you want to see that. Okay, see none. All right. So these are the main operations that you'll use in Python. Um, Almost all the machine learning I've ever done, and any of the work I've really ever done, has been using these, except for select scenarios where I actually needed those binary operations. Okay, let's talk about how to print in Python. So the next thing is printing. So um, very simple. There's a print statement in Python. No printf, no sprintf, no nothing like that. It's just simply print. And so if I want to print, I don't even have to say anything. I can just say print x. And that will just print out x in the terminal. So I will put a, whoops. I'm going to comment out all these lines. And then I'm going to print x is divided by 3. Okay. Can someone tell me what is going to be printed out if I wanted to run this code? What would you expect to be printed out with this code? If you have a calculator. Yes, that's right. It's float. Yes. Yeah. So Python will actually execute this statement and will convert it to a float. So let's try that out. Okay, so I'm going to save this. And you can follow along if you're following along. Go to your terminal. Make sure that your Python is there. So Python -- version. Okay. And you can see it shows Python 3.9.5. That's just an extension I have. And I can list everything in this directory, and I can see I have my main.py right there. Okay, so how to run main.py. How would I actually run this code that I have here? To run it, and I'll put these side by side now, since we're in that part of the tutorial. To run it, all I would write is python main.py. I'm going to make this a little bit bigger so everyone can see. Clear. Let's go like that. Python main.py. Yeah, so whoever put float, you're right. It's a float. Why is it a float? Because I use the division operator. If I wanted to make it an integer, do like this, what would you expect? If I did x integer divide 3, what would get printed out here? Any ideas? An integer, right? And it's going to be 21. Oops, gotta save it. There we go. And then let's clear it and reach send. And there we go. We get 21. Perfect. Now, a lot of you might be thinking to yourselves, well, you could have just done that in a separate line, like that, and then printed it out as x. And you'd be right. So if I save this and I run it again, yeah, I do get 21. But what happens if I wanted to print two different types of operations to 3? Let's say I wanted to do something like so-and-so divides so-and-so, and the remainder is so-and-so. So let's say I'm going to remove all this. I'm going to say x again is 64, y is equal to 3. And I want to tell you what the integer divide part is and what the remainder is after it. So how would I do that? Well, some of you might think, well, you could just do something like print x is 3, and then y, and then say something like x modulo y. And yeah, you'd be right. I could totally do something like that. I gotta save it. Keep forgetting to do that. And yeah, I can get 21 and 1. But how do I actually put this into a string? How do I say 64 divided by 3 is equal to 21 remainder 1? And this is where a new thing in Python that has been introduced since 3.7 called f-strings is handy. So f-strings work as the following. I want to make a string, and I put a string at the start here. And I put an f to say that this is an f-string. How to use this f-string? I'm going to say this first number. So I'm going to say x divided by y is equal to x divided by y remainder x modulo y. Now what's wrong with this? What's wrong with this print statement right now? If I run this code, you'll actually see it literally prints out x and y's. It doesn't put the numbers in there. In fact, this is no different than if I had just written so if you want to see the output of your Python code in Visual Studio, I'm going to open up Visual Studio right here real quick. So let's say you have your Python file here, open up in Visual Studio, like that. You'll see next to your number 1 on your keypad, there is a backtick, and you're going to hold your control key and then you're going to press backtick. And the backtick is going to open up this integrated terminal down here. And then you should see that you should be able to run something like Python main.py here and see the output as well, right there. Let me know if that worked. Okay, so one of the problems here is that this is actually not putting anything in there. While I have Python, I'm getting PowerShell not finding Python. Okay, so to fix that error, do you know where you installed Python? Okay, so close PowerShell, and I'm assuming you're on PC. Close PowerShell, and you'll go to your environment variables. Now you do need admin permissions for this on your computer. So you're going to see something like that pop up. And then in your environment variables, you're going to go to your system, or you could go to your user, doesn't matter. I'm going to go with system. And you're going to go to your path system variable right here. You're going to press edit. And then you're going to put a new line right here. So you're going to say new. And then you're going to insert the path to your Python executable right there. So you can see for me, I have it at the top right here. It's at C Python 3.9. Okay, so as long as you know where you've installed it, you can just put the folder path into your path environment variable. Okay, okay, apply, and okay. And that should fix it. Let me know if that works. Okay, going back here, we have x divided by y is equal to x integer divide y remainder x modulo y. Problem is, we're not replacing the numbers. Now, how do we do this with f-strings? F-strings are really nice. We just put f at the start of our string, and then we wrap whatever variable we want in curly braces. So I'm going to say that that should be executed. That should be replaced. That should be replaced. And this final part should also be replaced. Now you're going to see something interesting happen. If I run the same code again, would you look at that? So an F string is a format string. It says that everything that you want to actually put into it, you have to wrap in curly braces. So I want to actually put in an x, whatever the value of the variable x is, it'll replace it in. and it'll make sure to keep that space that I had there. So I'm going to remove this space here, remove this space there, and that's it. Now, what some of the student of you might think, okay, but then how do I actually print out um, an actual curly brace? How do I print out curly brace around X? And to do that, it's a double curly brace. X, and then double curly brace at the end. Now if I run this, you're going to see a curly brace around X get printed out. And that's how you do that. So if you want a curly brace to get printed out, just do 2 curly braces of the same type. Otherwise, it'll think it's trying to replace something in there. Okay? So that's how to print statements with F strings. Really useful. To give you an idea of how it used to be before F strings, so a lot of the Comp 1012 students might have learned something like this, where it would be something like 0, and then you would have to do something like dot format X, like that. And I'll let you be the judge. Which one is more readable, the F string version or this dot format thing with the weird numbers? Yours first. Okay. Any questions? We're about halfway through the agenda right now. How's everyone feeling? Were you able to get the PowerShell error fixed? And I'm assuming you can see the Visual Studio output now as well. Hopefully. Yeah, let me know if you still if the problems are still persisting and I can fix that up. Okay. Let's move on to the next thing. Still I can't see the output. Okay. So when you open up Visual Studio, you can see something like this, right? You're able to see something like a main.py being shown. Yes. So then, if you go to, where is it? View. If you go to View, there should be a button here, say Terminal. So under View, Terminal, and if you click that, you should get this terminal open up down here, right? And then you should be able to type here Python -- version and see an output there. And if you can see an output there, and it's not giving an error, you should be able to just type Python main.py, and that should work. Let me know if you can get this Python version working, and then we can come back. Okay, so let's talk about lists and sets. So these get into a little bit more complicated objects in Python. Okay. Say, for example, I have a list of fruits that I really enjoy eating in my smoothies. So I like kale, I like pineapple, I like a little bit of cashews, maybe some chia seeds inside there would be nice, and let's say some mangoes. But some of these, unfortunately, aren't fruits, so I'm going to remove them. And we're going to just keep these 2 right there. And I'm going to add another one, maybe something like bananas. Okay. And a kiwi. Okay. So I have a list of fruits here. Now, can someone tell me what this list is? What type of variables do I have in this list? Yeah, Python 2.7.16. Interesting. Okay, well, we can fix that later. we do have the recording here, so you can come back later and see that recording. It's going to require me to go in and do a little bit of changes to the path variables there. Okay, yeah, so this is a list of strings, right? And we can see if I do print fruits, it's going to try to print this list. And you can see it literally prints out the list, exactly how I had it. Some of you might be thinking, well, in C, yeah, you had to have it as, unless you had like a void pointer or something, all of these had to be the same type. In Python, that's not so much the case, actually. You can have literally any type inside of a list, and it should work. Let me save this. And you can see I can even have a list inside of a list and a number inside of a list, along with strings inside of a list. It doesn't actually matter the order of all these. Python is a little weird like that. It's called a soft type language, I believe. So it just means we don't actually enforce any types onto variables. You can have whatever type you want, and we don't care. And that could be problematic. And we'll talk about in the intermediate workshop how we can actually fix that issue later on. Okay. What's the next thing to do here? Let's say I want to print out these fruits one by one. I don't want to print them out in this ugly syntax of list. I want to say something like, Mahir likes this fruit, Mahir likes this fruit, Mahir likes this fruit, Mahir likes this fruit. Okay. All right, so I'm going to say something like, my name is Mahir. And okay, let's do a type of for loop. So the first type of for loop we're going to talk about is a direct for loop. Now I'm going to start with the direct for loop because most often that's the hardest for people to learn. And it's best to learn it first, and then you can learn about more other ways of looping that you probably know from other languages. In Python, a list is what's called an iterable. You can iterate over it, right? You can say that there's a first, second, third, fourth, or at least there's some elements inside of it which we can loop over. So I'm going to say for fruit in fruits. Now this in operator is going to consume the fruits list, the iterable. And it's going to assign a new fruit every time of the loop into this variable called fruit. So what do I mean by that? I'm going to mean in the first iteration of this loop, the in operator is going to say, all right, pineapple, you go into fruit. Run the stuff in the list, go back out. All right, next time the in operator is going to say, all right, mangoes, you go inside of fruit now. Go through the for loop contents. Bananas, kiwi. And then when it gets to the end of the list and says, oh, there's nothing left, all right, we end that bit. Okay, but how do you actually do for loops in Python? For loops in Python are interesting, and unlike other programming languages where you have to have like opening braces and say like something in the middle, or if you're doing really bad programming in C, you would do something like a space like that and it would work. In Python, it's very simple. Just put a colon at the end and indent the next line. So Python has no concept of curly braces in your code. There's no such thing as curly braces in your code. There's only these colons to say that the next line is going to be indented by some fixed indent. And this indentation is what I like about Python. It saves a lot of time of like brackets not being in place properly, or having issues of like whether the bracket should go on the same line or whether it should go on the previous line or whatnot. Gets rid of all those unnecessary debates. Okay, so if I wanted to do fruits here, and I'm going to do 2 spaces. Some of you might choose to do a tab. Some of you might choose to do 4 spaces. It's really personal preference. I like to go with 2 spaces because sometimes I get something like really, really deep, and I want to only go up by 2 spaces at a time. Okay, so I'm going to say for fruit and fruits. And now we're going to use our previous knowledge that we know. How to do the print statement. So I want someone to tell me, I want to have like an output like this in the terminal. I want it to be like, Mahir likes, and then the fruit name. So something like this. Can someone tell me the F string that I would use to make that a reality? We know we have to do a print statement, but what should be the contents of this f string? And I leave that for a few minutes just to discuss. What do you think the f string would be? Feel free to unmute yourself. Feel free to talk amongst yourself in the chat there. This is really your time to check your knowledge of what I taught in the last one. So how would you do this f string? So the first thing you might consider doing, asking yourself, is how do you get the name? Very close, Daniel. Yes, that's right, Pig. Yes, name likes fruit. Now, it's important that you say fruit rather than fruits. And I'm going to show you the difference between it. So yes, we have our name, likes, and then I want to say something like fruit. Now, if I did something like fruits, you're going to see something really interesting actually happen in the output terminal. Let's do it clear. Python main.py. You're going to see that if I try to print out fruits, it's actually going to print out the list of the fruits rather than what I'm iterating over. If I put a remove that s at the end, now I'm going to use this variable, you're going to see something interesting other than that print out. And you can see every single time that I went through the loop, the value of fruit changed. I did pineapple, then mangoes, then bananas, then kiwi. Okay, so there are different types of fruit that I like, and this is how you show them. For fruit in fruits. So that's one way of doing it. Okay, let's talk about the next way of doing it. Next way of doing it is with indexing. So again, this is a list, and like other programming languages, each list has an index. So this is, and like a lot of programming languages, not like MATLAB, we start at 0. Then we go to index 1, 2, and 3. So the list is 4 long, but it only indexes from 0 to 3 inclusive. And we'll talk about negative indexes maybe at the end. Okay, so if I wanted to print out these based on index, how would I do it? I would say for, let's say, for I in range. Now there's this function called range, and you can see it tells me what range is all about. You have a stop at the end. You can add an optional start and an optional step at the end. And it says it returns a range of I plus 1, I plus 2, all the way to j minus 1. Okay. If I don't put a start, it will default to 0. Okay, so for example, I have range 4, returns 0, 1, 2, 3. So I want to say range 4. And I want to print that out. So print I. And let's see what happens. Any guesses before I print it out? What do you think is going to be got printed out here? 0 to 3. That's right. Yeah, just straight 0 to 3 with a new line at the end. Very good. Okay, now I want to use this as an index. So some people might say, well, I want to go for the 0th index of fruits. So I'm going to type in a 0. What's the problem with doing it with the index 0 here? This is a very common mistake. What's the problem with doing print fruits 0? That's right, it's going to print pineapple 4 times. We're not actually taking use of any of that I stuff, and actually I might as well just use an underscore, which is a throwaway variable, and say I don't care about the I. But I do care about the I here. I can show this. I do care about the I. I want the I there. I want the I to change as the index changes. So I'm going to put an I in here instead. And now I get all the different ones. Okay, so I want to name these. This is called a direct for loop. This one down here is what I like to call an indirect for loop. At the end of this, when I talk about the while loop, we'll talk about why there's this difference between indirect and direct. Okay? All right, last one, while loop. This is very manual. We have to say our variable I at the beginning. So we're going to say I is 0. Okay? We're going to say while I is less than the length of, or sorry, 4, while I is less than 4, so we can't index 4, but we can index 3, print fruits I. And that will give us the same results as before. But what happened here? It's a very manual thing. So one thing I have to do at the end is what? Why is it just spamming pineapples? Does anybody know why? Yeah, that's right. I never reach 4. In fact, I'm not actually changing I. It's just staying 0. And that's why it's pineapples always. Love pineapples. You gotta do an I plus equals 1 here. Clear. Save it. Python main pie. That's how you do it. Okay? So a couple different ways of doing it. And I'm gonna replace this F string in all of these. Okay. So this is called a while loop version. Okay. So let's talk a little bit about why there's this distinction that I made between the direct for loop and the indirect for loop. The reason for this is very straightforward. Direct for loop means that we can only directly access the fruits variable. It's already defined, really. Meaning that if I wanted to change fruit, the value of fruit, it doesn't actually change in pineapples. Okay? It doesn't actually change inside of there. And I'll show you what I mean by that. So let's say I wanted to do something like strip the S at the end of this. Strip the S at the right side of this. Okay? So this R strip method, we'll talk about that later, strips the characters from the end of the string. So I should just get pineapple, mangoes, pineapple, mango, banana, kiwi. And we'll see that get printed out here. And you can see that it gets printed out, and that's the end of the story. And even if I try to do it something like this, let's say I try to do something like fruit equals fruit dot R strip S, like that. So let's say I copy that out, put it there. You can see same thing gets printed out. Okay. One thing to note though is if I bring back the while loop version, one thing to note though is that it doesn't actually change it. So pineapples still stays pineapples, mangoes still stays mangoes inside of this list. For the indirect for loop, I'm not directly accessing this fruits from the fruit like that. I'm indirectly accessing it outside of the for loop. You can think about it like that. And really what that means is that if I have this line here and I paste it in and I change it to fruits I and this also to fruits I, now you're going to see something other than that get printed out. So there we go, and there we go. Okay, save. Now you can see if I do the indirect for loop, it will actually take out the S from it. It's actually modified the value that I had inside the list. Okay? So there's a direct way to index, and there's an indirect way to index, and then there's the while loop version. 3 different types of loops that you can use. Okay? Any questions from anyone on that? This is pretty important if you want to do stuff that has to modify the values as you're printing them out. And has to like store it intermediately back into the value. So fruits I. If you want to store it back, you probably want to use this direct for loop method. Okay. Another problem with this indirect and while loop version is we had to put a constant number in here. We had to get this constant 4. Whereas take a look in this fruits method, this first direct loop one, there's no mention of any numbers in here. It's very almost like English writing that we just put it in there. Now, some people might say, well, sure, you can get the length of the fruits. Okay, yeah. But I'll let you all be the judge on your own to say which one of these looks the best. Is it the one that has range len and then put an I, or 4 lines for the same thing? Or is it just something simple like this, where I just need 2 lines really, because I can replace this back into here. You be the judge. Okay? Any questions? Does everybody understand the 3 different types of for loops that we've gone over? Anybody have questions? No? Okay, cool. So I'm going to assume that everybody understands this perfectly. All right. Next thing we're going to talk about is functions. All right. So let's say, remember this time in probably high school math where you had to do composite functions, and it was talking about like how the different types of operations matter in the order that they're applied. But we're going to do a little bit about that. Okay, so we're going to say there's a function f, and how do I define the function f? In some programming languages, it's just function. In some programming languages like C, you just output like that, and that's a function. In Python, it's a little bit simpler and a very few number of characters. It's called def, so define. And we're going to define a function. It's going to be called f in our case. No variables get passed in, and we output something back. So we're going to just say for now pass, meaning don't worry about it. We'll come back to it. Okay, we're going to define another function, g. For now, we're not going to worry about it. And then we're going to say something like, is it linear? Okay, we're going to say, is f and g linear? So how are we going to test that? So let's say f takes in an input x, and it's going to output something like x is equal to return something like x plus 2. Whereas something like g is going to give back something like return x squared. Now obviously one of these is linear, one of them is nonlinear. And how are we going to really test that using Python code? Okay, well, if you remember from the definition of linearity, we have the idea of homogeneity. Sorry to get technical on you. And what was the other one? Homogeneity. Sorry, lost my train of thought. Axioms. Superposition. That's right. Thank you. Sorry. Don't know why I lost my train of thought like that. Okay. So we have homogeneity and superposition. So the idea here is that I would want to do testing. So I'm going to assert something. So assert just means make sure it works. Assert that, we're going to have to put an input there. Assert that f of 3 plus whatever number we want, 2, is equal to f of 3 plus 2. Okay? So that should work. That should say that it doesn't matter if I add 2 on the inside or the outside, it should still work. And let's try it another way. Let's do something like f of 3 plus g of 3 should be equal to something like f of 3 plus, sorry, f of 3 plus f of 4 should be equal to f of 3 plus 4. Okay, and then we'll do the same thing for our other function g. So assert that g of 3 plus g of 4 is equal to g of 3 plus 4. So let's try something like this. We're going to save it and run it, and we get an error. What does it say? Assertion error. F of 3 plus f of 4 equals f of 3 plus 4 is false. Okay. Why is that? But we have plus 2 there and plus 2 there. Okay, that's probably it. So let's try something else. Let's try proving, shouldn't it be f of 3 plus f of 4? Not sure if I understand. Oh, you're saying like the equated statement here. No, it's just because I think I'm messing up this example. So let me try a different example actually to prove the idea of functions here. So let's try doing something like print f of 3, for example. So I'm going to print f of 3, and the function is going to give back 5. Now let's try doing something else like f of 2, and that should print out 4. Okay, let's try doing a for loop version of this. For I in range 4, print f of I. So I can put in a variable in there, and that should also work. And you could say 2, 3, 4, 5. What if I did g instead? Okay, I can do g, save it. Gets the same thing printed out, this time it's squared. I can even composite functions inside of each other. So I can do f of I inside. And if I save that, you can see we get 4, 9, 16, 25. But what if I wanted to go the other way around? What if I wanted to do f of g of I, or x in this case? So I'm going to put g on the inside, f on the outside. And we can see we get a little bit different numbers. Now it's being squared and then added onto. So you can actually compose functions like that as well. And you can do assert statements to assert your assumptions and whatnot. I a little bungled up that homogeneity stuff, but the point is that you can composite functions, you can put anything inside of any other function as long as the input is what you expect here. Okay, what if I wanted to do stuff with strings, for example? So I want to have a method that we'll get a string and we'll check if it's palindromic. So palindromic means that it's spelled the same way backwards and forwards. So how would I do something like that? Okay, so this is a very common example. Let's say a function here, we're going to call it define, is palindromic. And I'm going to take in a string, let's call it string, and we're going to return either a true or a false. One thing you'll notice in Python, though, that's really annoying is that there's no such things as type definitions. We don't have types or anything. And if I wanted to see later on what palindromic is, I don't know what it refers to or what it sends back up or what it takes as an input, what type is it expecting. So there's this thing in Python, new in Python, where you can actually say and give hints on what type you are expecting out. So I'm going to say that palindromic, so this string should be a type string, and it's going to return a Boolean value. Okay. So how do we check that? So the first thing we're going to check is is this a string of 1 or 2 characters? If it is, then it's definitely palindromic, because an empty string is palindromic, and so is any single character on its own. So let's say that is an if condition right there. So if string, or length of string, is less than 2, we're going to return true. All right. The next part here is we need to say else. So the length of the string is larger. We're going to ask, does the first character of the string equal the last character of the string? Okay, so what does that mean? We want to say, does the string first character equal, now how do we get the last character of a string? Does anybody have an idea of how we would get a last character of this string? So for example, if we have race car, first off, how do we get this R at the beginning? That's with the index 0. That's pretty straightforward. How do you get the last index? Does anybody have an idea on that one? Length string minus 1. That's right. Carl, yeah, you're getting a little advanced there with the negative indexes, but you're completely right as well. So another way of doing it is we're going to say length of the string minus 1. Now when we think about that mathematically, race car has 7 characters. We want to get the length of race car, so that's 7, minus 1, that's 6, and we're going to index it at 6, which is that last R at the end. Okay, so we're going to say, does the last character and the first character the same? But then what's the recursive idea in here? We want to also check what? What do we also want to check? We probably also want to check if the inner part of race car is the same. And this is where we get a little interesting with how we type Python. In C programming, this would be really hard because you'd have to pass in a few other parameters and say, okay, I'm keeping track of the first index and the last index, and I need to make sure that I'm doing proper assertions to make sure that works properly and whatnot, or I need to allocate a new variable for the new string. Not at all in Python. In Python, we have what's called slicing, or splicing as JavaScript developers call it. And that is to say, I want to check, is palindromic, so obviously I need to check is palindromic, but what do I pass in here? I pass in the string, but I only want to slice the string. Okay, where do I want to start my slice from? The A, right? And what is the index of this A? Does anybody know the index of this A? It's going to be index 1, that's right. Yes, that's right. It's going to be index 1. Now where do I want it to end at? I want it to end at this A, right? The A at the end. But how do I say I want you to end at the A at the end? -2. So this is an interesting thing. This index at the end that I want to slice in it's exclusive. We say it's exclusive. So if I said -2, that'd be that A, or that'd be similar to saying the length of the string -2. That would mean actually we end at the C instead. So rather, what do I want to do? Just -1. So this is the syntax for slicing in Python. Start with your initial slice, a colon, and then what index you want to end your slice at, not inclusive. So if I want to end at the length -1 string, so that's the R, it's not including the R. And we can see if this works. So we can see, for example, is the string, so print, is the string palindromic for race car? And let's save that, Python, and we can see it's true. Let's just make sure that's not just it's always giving true. Let's say something like ASDF, it's false. Okay, so that's a little bit about indexing and splicing, but we can take this one step further now. Okay, so as Carl said before, you can have negative indexing. What does negative indexing work like? So let's say, for example, I bring back my fruits array. So fruits is going to be pineapple, it's going to be mango, kiwi, and maybe a grape this time. Okay, so before, actually I'm going to make this apple. Before, this would be given index 0, this is index 1, 2, and 3. But Python is really interesting in that everything is also given a negative index. So this is actually negative index 4, negative index 3, 2, and negative 1. So everything is also assigned a negative index. And instead of doing length string -1 like we would do in other programming languages, Python lets us use these negative indexes. So we can actually put in -1. And instead of here, we can put in -1 as well. Makes it a little bit more distinct. Save it. And we can still see we get the same results as we did before. Okay? So there's now a thing called slicing in Python. All right, let's try a little bit more into slicing here. So another way that we can think about slicing is the following. There is a start slice, an end slice, and a step slice. So regardless of whether we use positive or negative, does a slice go from left to right? That's correct. Yeah. Yeah, it does. There's cases where it won't, but we'll actually get into that right now. So almost always it will go from left to right in the slice. So if I did from, let's say, -4 to +2, I should expect to see pineapple and mango get printed out. Because remember, the end index is never included. Let's try that out. Let's just make sure about that. So I'm going to print out here fruits, -4, 2, 2. And let's see what we get printed out. And there you go. Right? So it actually doesn't matter whether you use the index of negative or 4 or 0. It will still go from left to right. Okay, a little bit weird, but that's okay. Let's talk about this step slice though. This is where things get really interesting. Step slice tells us how much we should step over this kind of loop here. So I'm going to add a few more. Actually, I'm not going to add any items because that would ruin this numbering. Let's say I wanted to step through mango and grape, and I wanted to skip pineapple and apple. Okay, so I'm going to start at mango. I want to go to the end of the list. So when you actually want to go to the end of the list, or you want to start from the start of the list, you don't have to put that number in there. So for example, I can put nothing in for end, and it'll know to end at the end of the list. And then I want to say how much I want to step by. So if I want to start at mango and then step to grape, what is my step size? Does anybody know? What's a step size? 2, that's right. Yes, it's indeed 2. So I'm going to do print fruits 1 to the end, step size by 2. And if I print that out, we get mango grape. Okay, challenge question. How do I get it to now, with one character, I'm going to add one character to this print statement, and I want it to print from grape and then mango. How do I get it to print opposite direction, right to left? I encourage anybody to give it a shot. That's right, negative. Put a negative at the start of the 2. Putting a negative at the start of the 2 or any number at the end of this, putting a negative there, will actually reverse it. And we're going to use that in a couple of seconds here. So I'm going to save that. Oh, what happened? What do you think happened? It started from index 1 and then started to go back by 2. So I lied a little. All you have to do is move this number away and then go, or yeah, you can do it from 3 like that. And that will also work. Okay? A little bit of a trick question. Sorry. All right, but there's also another way of doing that. You could also go go from grape and go to mango and then pineapple. You can go from reverse it from mango and then loop over to grape. That's a little bit advanced though. Whole a lot of different ways. Point is, start and step. Some of these you can leave optional, and I'll slice it on its own. So for example, if I wanted to go from mango to the end, or sorry, apple to the end, I'll do 2 and then nothing for the end slice, and it'll print out apple and grape right now. Okay. Okay, let's use this for is palindromic. Now, how do we actually employ this? Okay. Well, think about it though. Let's say I have this variable called race car, and I'm going to say that this is our string s. Okay. How do I reverse this string s now? Remember, there's no such thing as a character in Python. Even a string, like a string like race car, is really just a list of characters. There's no such thing as characters, it's just a list of characters that are strung together. You can't actually access it. How do I reverse that string of characters though? If you think about it in terms of step sizes, how would you go through it? Would I want to start from the start? And I want to go to the end? But what direction do I want to go in? If I want to reverse? Backwards. And we knew that if you added a negative to the step index, it'll make it go backwards. So yeah, if I did ::(-1, we get race car. But you don't see that. Let me try something like my name, for example. Whoa, there you go. That's pretty cool. So now, in our isPalindrome function, we can do a test condition. We can say, does this string equal the same thing as the string, just reversed? Now we can do something like isPalindromic s. False. Oops. Race car. True. A very popular question that they give to Competent 12 students on final exam is check if the string is palindromic. That's how you do it. Okay. Last thing I do want to go over is talking about packages. So how do we do packages in Python? So let's say, for example, I want to use the random package. Now this is, I'm pretty sure, installed by default on all Python. So I'm going to do something called an import statement. And that's like an include statement that you would see in C, or it just like the same import statement that you'd see in JavaScript. They're all basically the same. This is how you bring stuff in from other modules into this Python file. So I'm going to do an import, and in this import statement, I'm going to say from random import random. So I'm going to say import from random, import this random library. And that random function is something I can print from. So just to give you an example, I'll do print random. And random always gives me some random number between 0 and 1 inclusive. Okay? Why do I want to do this? Because now, if I open up Paint here, assuming that random gives us a random uniform generation of points, I can bring up something like a box, and I can divide it like this. Okay? I can say that, let's say this is a Cartesian plane, and I want to estimate the value of pi. Well, I know if I have a circle like this, the area of that circle is given by pi r squared. Now let's say this goes from 0 to 1 to 1 to -1 to -1. For our sake, since the random function only goes from 0 to 1, we're only going to consider this range of values. And to know whether that lies in the circle or not, we just need to say, does r squared, and we know the length of this circle is length 1, does the point lie in this quarter circle? If it does, it's part of this circle, and we can calculate pi using it. Otherwise, it's not. So what we're going to say is essentially this. Does the point, for every, let's generate some random number of points. So for point n points. Okay. Does your x, if your x squared plus your y squared is less than 1, great news, you're inside of the circle. So we're going to put you into the circle stack. So we're going to say count plus equals 1. Okay, we're going to add 1 to count. Otherwise, don't do anything. And at the end, we're going to print count divided by the total number of items. And if we did that right, and this was a random uniform distribution, we should get pi divided by 4. Okay, let's try it out. A little bit technical in the math, but I just want to give a little bit of background of what we're trying to do. So let's say a total is equal to 10,000. Okay. One thing you want to know in Python is if you're typing in large numbers like this, you can put an underscore in them, and it makes it a little bit more easier to read. Okay, let's try a different thing now. We're going to say for whatever, we don't care about it. We're going to say for range in the total. I don't care about the I. We're going to generate 2 random points. I'm going to say x is equal to random, y is equal to random. Then I'm going to say if x, now how do we square it? Can someone tell me how I can say if x squared minus plus y squared is less than 1? How would you write that in Python code? How would you write that? How would you write x squared? Yes, yeah. Yeah, so there's 2 ways. You can do x times x plus y times y less than 1. Or you can do x squared plus y squared less than 1. I haven't tested it, but I'm pretty sure x times x is a little faster. But just so we can do a little bit of practice with the fancy Python notation, we're going to use this double star syntax. Okay, less than 1. Then I'm going to say count plus equals 1. At the end, we're going to print out the approximate value of pi is, and then we're going to say get the count divided by the total. But then, what do I need to do? Multiply by 4. Okay. if I'm not mistaken, my math's not wrong, that should print out an approximate of pi. Let's do clear python main.py. Not bad, right? We can actually increase the amount of samples that we do here. My machine's relatively fast, so I should be able to do 1 million samples. Oh, we got a decent value of pi. But what would be a really smarter way of doing it, and it's been shown that 22 digits of pi is more than enough for almost every application, we can import this value from the math library. So you can say from math, import pi. And then we can just say here at the bottom, print the real value of pi is pi. And that's it. That's how you do basic package and function importing in Python. And you can see the power of everything that we've learned so far. We've learned about for loops, we've learned about function calling, we've learned about the different mathematical operations, and we've learned about f-strings. So that is the basic of Python programming. Any more than this, when we get a little bit advanced and we talk about stuff that were in the upcoming workshop, where I'll talk about string comprehensions, classes, and more about like inner and outer functions. For now, this is good enough. Are there any questions on anything that's been taught here? Does everybody understand this? Hopefully? Okay. Perfect. So let's go back to the slides here. Yeah, so that's pretty much the end of this workshop. I hope you learned a few things. I hope you feel more confident in your Python programming. Please review the slides, especially that agenda that I have here. Ask yourself whether you can list off a few types of variables, whether you know the mathematical operators, if you understand f-strings, and have some fun. Try doing a little bit of programs that you've done already and rewrite them in Python and see if you can do that. And you can always use package or functions from other libraries to get what you need to do done. Okay, last thing I do want to mention, as I said at the beginning here, is this is a 3-part workshop series. So there is a Python programming one, which is this one, the introduction. Then we go to the intermediate Python programming, and then we talk about how to program AlphaZero with TensorFlow, which is really cool. For those of you who don't know what AlphaZero is, there's a really great documentary online talking about how it beat the best Go player in the world. And they showed how modern programmers can now create AI applications that can beat almost any sort of human at any deterministic game like chess, Go, Connect 4, or anything like that. So I do recommend you, if you want to attend these other 3 workshops, to join UMIEEE. The link I will copy and paste into the chat here. You can always reach out to me if you have questions on how to register. We have a member exclusive lounge, not really in use right now because of COVID and everything being online. But our lab is really useful for graduate students or students who are planning to do capstone projects. If you're part of a tech socket as well, it's really useful. We have a high performance computer where you can do the machine learning on. We have breadboards, Arduinos, resistors, literally anything you want as part of the tech shop as well. And we have planning some industry tours once everything is back in person. Okay. If you have any questions, please ask them now. Otherwise, thanks for attending. And yeah, thank you for being here. It's what makes it fun. And yeah, if you have any problems with your IDE, we can sort that out so that you can watch this lecture afterwards or this workshop afterwards and fix it up. So I'm going to pause the recording now.